think we can start it. So with creating model with trace is not that. First click and I'm already made a mistake. Yeah, that's not very good. And when we have this new model and we can start modeling it, then you just take this select component inserting option here, and then you perhaps see that, I'm not sure if you can see anything from the screen, but hydraulic components exist, and then there are pipes and all the necessary things out here. So pipe is, if we just take the whatever the geometry factors are somewhat close to the at least what other parameters we can use. Whenever it was given here. So the geometry thing was that it was total length, so this is concerning the actually these pipe 1, 2, 3, and 4 are made for the APROS approach, but we knew that the whole facility was given the values of height of 11.2 meters, and then water level should be set to 7 meters, and then this horizontal pipe should be attached at the level of 10 meters. So these are the trick points that we should take care of. And the hydraulic diameter, we can check out what it could be. Again, scrolling a little bit, unfortunately, yeah. And we see that vessel, pressure vessel cross-sectional area is given here, not the diameter, so we have to do some calculation, but I think that is somewhere. I don't put the correct values, I think I put some values here, and then you should calculate your more precise values. Hydraulic diameter I put here now, but I guess it was something 70 centimeters. And then number of cells could be, because it's 11 meters high, then I presume that could be something like 20 cells, and the orientation is vertical. So these are the basic things for the vertical pipe. And then we get it, and it looks like this. It's very thin, and so what we could do is scale it a little bit, scale the drawing. Here is the right hand side bottom of the mouse, and then you can do some scaling. Maybe not length, but to see a little bit more look like some kind of vessel, then you can move the width larger. That was the case. And what we can immediately do here is this, putting the initial conditions, which are in red there, and then we can check out that for the boiling water case it was 70 bars, so it's a 7
11.2
e to 6, which is a 7 megapascals, and for that it gives me the
saturation
immediately the numbers here.
0.7.
And liquid
This one is
temperature is then
0.7.
not what
This
we
one is
wanted.
11.2.
Oh, sorry. This 7?
So it's
0.7.
286, which requires
6. That's
in
in Celsius
Kelvins
though.
is something else.
So plus 273. So
But
it's
I think we can assume
And
it
number
is
same, number
saturation
five to one?
conditions
Yeah.
which
To
are
one?
here
this one is 20
already, so we
Oh,
don't have to
okay.
do anything
and this one
for
vertical.
that.
This one, 40?
In order to
One.
check out
Vertical.
Oh. Why I
the
didn't,
You drag it, need to drag it. Click and drag it down.
valid conditions. But then, when we want to set the level somewhere, and we don't really know where it is now, but if we want to consider the level is somewhere, then we can put the gas volume fraction, which refers to the fact that it's a steam there. Then we have to put the gas volume fraction to 1, so that we say that it's steam. Steam is then I tried this one now. I imagine that my
The top string
level
for
is
22
here
level.
at this cell number 17. So now I have to emphasize that this is really not, I've not checked everything, because now there's not been any manipulation yet with the nodalization,
Initial
which is
conditions.
really needed in order to set
The pressure is 7
the
megapascal.
level into correct
So
place,
786.
and also to set the, as
Make it
we
on.
have here,
Yeah.
this horizontal line pipeline into some certain level of 10 meters, but that you have to calculate yourself and check out that it is in the correct
The
place.
top 3, it's 1.
One?
So
Yeah, until 17.
this model, which
From
you
20
have in
until
the
17.
instructions, seem to have 22 nodes, so you can increase the nodes yourself simply with manipulating the model. So if you like, you can then
And that's it?
re-nodalize. There is this option for re-nodalizing. And doing the re-nodalization works that way that you just pick up some of these nodes, and you can then, if you want, for example, split these 4 top nodes uniformly into 2, then you can just do the split uniform and then put here 2. Then you can put more nodes there. Now there are, you can check that now there are 24 nodes already. And if you like to do the re-nodalization again in some other points, then it's perfectly okay. And it gives your answers
If
for
it's
that.
4.
But if I don't care about how realistic or how well this is
Let's start it.
obeying the rules of the instructions, so I will continue, but I will give the horizontal line by adding 1 pipe, and pipe which is now something different from
That's 20 or 90.
pipe length is first 47 centimeters,
I don't have that.
and then I have to do that.
The one in the top. You choose.
Hydraulic diameter is then something very much,
I think it's the
less.
same if you want new pipes.
Mhm.
It's the same thing.
maybe 20. I have to check these also. Number of cells is doesn't have to be maybe 2 nodes or so. And then it's a horizontal pipe. This way you can really easily do and then again scale the drawing by length if you like, and then scale
many
the width
that's it?
as well.
Only 2 this one.
So it looks a little bit more comfortable
And
here in the
vertical.
screen.
Horizontal.
So it doesn't affect to the actual values, only the visual system as such. And then I have this valve component, which I can also add attached here from the same hydraulic components. So the valve, but then the length would be the same, I think. Valve length 47. And then what you have to take into account are these cross-sectional areas to be correctly. But these are now, I don't care about those. Those now.
What's the point?
And then hydraulic diameter is
0.2.
I presume it's quite small now. It's again horizontal. I can want to enlarge this view again. So I do these quite quickly now that I hope that you can follow these operations. But, they are quite straightforward things, and we can practice that more. And then there is this brake pressure boundary, which is can be also attached here, and change the orientation of this so it points to right hand side.
Yes.
And then what is then we need is to attach them
These two times.
together or connect them together.
Is there 6?
Into what point I want to do that, I can now choose arbitrarily something that would be there, and then connect all these this connection to, which is that part. You can see that you go there and it turns to connection to. Then you have all the necessary components attached there. Then you have to do go back to the pointer mode and attaching some values here, all different values, and I presume that this
76.
this pipeline would be in a
76.
so I presume that it is in a
Five.
such a state that it's a
75.
gas or saturation conditions. 70 bars, which is 70 megapascals.
70 points, so 76.
So, and then also for valve, the valve is important in that sense that we assume that the valve is on the other side is the first node is in the conditions which this vessel is, so 70 bars. It's okay, and then it's a pure gas or steam. On the other side, we can assume that it is in atmospheric conditions because
So
we have
it's
a
1 bar.
closed valve.
So 1E5.
And here the boundary is here, and so we can put here 1E5, which is the atmospheric. So the temperature here is not really important. It is only the pressure difference what this is looking
Professor.
here. Yes.
So for pipe 20, the gas volume fraction is also 1.
Yes. Because we assume that the
Yes.
level is below this.
Below, so it's all
this
gas.
connection.
Okay.
But for this model which I'm building now, it's not
Okay.
it's not correct
Yeah.
because I do it in a you should check every details though, so that they match with the instructions. Where this actual line is connected, then it should be in 10 meters.
Okay, exactly
So
10
you
meters.
have to calculate how many
The each node.
this is, and then because it's in a half, in the middle point of the
Okay.
node, and that's also 1/2 of the of this node length.
Ah, okay. So
So
the middle
we-
node should be 10.
Yeah, so you need to make these nodalization changes, you need to adjust that it's in the correct position.
Ah, okay.
And also, then if you want to check the level, so that level is in some, between some of these, if this is covered, for instance, with water, then it's of course 0.
0.
And then above it, it's a
Above
1.
one,
And
that's
then
all
you
gas.
assume that level is
Level,
in
separate.
the edge of those
Yeah.
nodes. But of course, you can assume that it's in the middle of one node. And so
Also the.
then you put 0.5.
Ah, okay, so
void
it's.
fraction.
Ah, I see.
So that's a very simple trick.
Yeah.
But of course, when it first calculates balance, it might have changed.
Yeah.
So you might could calculate before you open this valve, when it maybe few seconds, 5, 10 seconds of the case such a way that it is let's stabilize a little bit, because it might, you just give values, then the code is asking what is going on here, am I happy or not, and then it changes the values. And this level thing might give some a little bit different, but of course if it's only a few decimals, it doesn't matter really. Okay, so you can continue giving these values, and also the outlet boundary, which was this break, and this also means the pressure value, which is then atmospheric conditions 1E5. And you can assume that it's this 373, which is so the temperature is not, there has to be something, but it doesn't really matter what it is, because there is nothing comes in from there. And this doesn't affect the calculations. Okay, so this one, I think most of the things are covered. And if everything is okay, then yeah, this might happen that the code complains something like here it is in red and says invalid values in the cross-flow connections. And the cross-flow means that specifically this connection here. So when there's a vertical pipe and then it's connecting to the horizontal, that means it's a cross-flow connection. And something has to be done to make the code satisfied. And then we can click this red and check out what is there, what we could do. And usually it is the angle which is complaining. So it doesn't know in which angle it is really, even though we have given that the other component should be in a horizontal position, but this is a very simple thing that we just put here 90 degrees, so then it's a rectangular towards this, and then it's oval. So these are some things that the code is a little bit not so intelligent. But we'd have to take care and give it these values. So nothing else is needed, I think. And you can, and then there are, what I just did is that I clicked here this red check all components in model, so it checks if everything is given, all the initial values have been given and so on, and then it gives me a list of possible errors, and now there are, for my model, there are quite a lot of these missing things or erroneous things, and so For the valve, I've not been careful enough, so I have to go check the valve. There are lots of red things here left, and I have to take into account. So most of these values are such that you don't really know what they are, but maximum valve rate. So valve rate means that how is it opening. So you can put, for instance, 1, and then off adjustment rate is the same. So it's just some values which we really don't use here, because we're giving the valve in such a way that we can change the option for the valve, but the minimum position is 0 and the maximum position is 1, and so on these. And here we can introduce the valve flow area, which was given here in the instructions. So the valve flow area was this 0.032. So these values we can attach here quite easily. And then we have to calculate what does it compare to the hydraulic diameter. So I don't know it by heart now, but you should calculate it. I put there something, some value which is not realistic, but 1 centimeter is probably correct. And initial flow area fraction, which is initially I think it's closed, so I put 0 and valve stem position as well, because it's the stem is the actual mechanical device which is inside the valve, but we can assume it's. So here is important that you fill all the things which are red, and then you can continue. Here is a thing that you can do now, because the valve type here is considered as constant flow area type of valve. So it is just a valve which doesn't move at all. But we probably want to make it a flow area fraction table, which is this number 1 option. So that makes our life a little bit easier to controlling the valve, but we have to do some table to control the valve here. So adjustment of the first adjustment of the valve is needed, and we have to give instructions here, and we can give a few lines adding there, so that here it refers that at the time of 0 the area fraction is 0, then it's fully closed, and then we can assume add more maybe after, if I put in 2 seconds it's still closed, but then I can put in time of 3 seconds I put it fully open. So this is a very simple way that I can control the valve opening. So and now the rest is it is kept open, so I don't have to close it.
Where did you open them?
This, yeah. So here is valve stem and valve flow area fraction. So can you find it? So no, sorry. First adjustment table. That was first one in gray. editing mode. Here you can add these, perhaps 3 lines is enough, and then giving these not that we're supposed to give these times, and then 0 and 0 and then 1. So this way I can do that. And then what I still want to do is that the code doesn't know what is the first column, what is it. So I have to pick the so-called independent variable, which is in a very, very low value table. Independent variable, it says none. But I have to give the information for the code that it is a problem type. So it's stupid enough not to know that, but of course it could be something else, but I can give that. Otherwise it will complain that it doesn't understand what my table is. And if I go back to this first adjustment table here and check out now it is should be available, so that's now it's okay. Fine, so now this valve operation is set. Of course, you can manipulate these opening as you like to be how you favor it to be. Okay, and then we can continue checking what could be wrong here, and then there are still errors, and usually these errors are related to this abrupt area change testing. It means that there is this large pipe connected to the small pipe, and then it complains that large area change detected in the junction area. Specify the loss values of the abrupt area flag, and that's something we can do. It can be given here in this horizontal pipe here by taking that. So if I double click that component, and then I can find the friction parameter here, and the friction is we can get this kind of view which tells now what kind of friction options it uses by default. And we can see that there's a flow factor plus friction, but in this case it's not enough because there is this abrupt area change taking place, and then we can, by clicking this, we can find the red E editor button, and then we can find that there's discover more friction, but an abrupt flow factor friction properly abrupt area, which is the -1 option, and that gives the order to the code that now takes care of this area change. And sometimes this is enough, and you can try by doing this very simple modification and try to again, but it doesn't really go through. So I specify loss values, so it gives me instruction, so I have to give here some loss factor value, which is the same place as we did the friction. We didn't put here, which is the K factor, which is related to this abrupt area change. You could check out those from the literature, but I could put here any value, maybe of 0.1, so that it makes a code happy again. These are some tricks that we want to, and then I try to still something is wrong, and then I have to do probably something else which can affect to the
Step back 20. Friction again.
and what is then usually related is related to this between the valve and the pipe. So I have to do the same things in here, the friction, and put here
Friction.
abrupt area change as well.
Number
Put
one.
here some values which I hope that satisfy the code. And then, okay, now I found a way how to work.
No.
So I have to pay attention first, because here's the big change here. I have to take care of this
You want with
connection.
his pipe more than
And then
regular.
there's this
You have to
pipe is
take
larger
it.
than this valve. So there is also here the same
His pipe is divided more than
attention
you.
has to be taken.
Yeah, it should be 20.
Okay, but I think this could be
Yeah,
a,
it's just one of he put like
that.
arbitrary.
So now you have something
In the
you
end,
can
it's
run
Horizontal.
case.
19.
19.
And I don't know what the results are, but what we are missing here is still the taking into account the critical flow. And
Is
then
this
we have to go through
Yes,
this,
it's called.
because this
Silent
requires
versus
also
structure.
some protection. So the
The
critical flow setup is by far it's not to default,
This one.
but you have to do it as it's said here, so you have to go to the model options first. And then you should find there name list variables. There's this kind of in the little bit lower part, you can find this kind of name list variables. And then there are quite a lot of these things that might be different to find. But there's an instruction set that is so-called IC flow option, and that you can probably find it by filtering just IC flow, and then you can find it from the choke flow options. So here is this. Could have found it without that as well, but I can show it where it really is. So if you just have this whole package and then you go to the very end of this, you can find this choke flow options separately. And you click that, then you get again the massive amount of different kind of things and of parameters. And here is the last one, which is concerning IC flow, choke flow model. And then you can tick this box, and as it said in the instructions that choke flow model visible, and then use this number 1 job flow model using default multipliers. So which is it's a little bit complicated, but you have to open this and then default, or was it optional actually? It might be. I think either is working, but the final choose, let's do it in the optional multipliers. I try this, and well, this has been done, it's okay, but then I have to go to the actual, where I want to put this working is in this valve component. And in the valve component, by double clicking that, you can find from the very same friction component. Now we can see that there's something happened because we have chosen this option for the choking flow. Now there are, this valve, there are these three, and everything says no choke. So there is no choke or critical flow checking, so I have to change that. And it is usually enough that I do it in some boundary edge. And if I do it here, so there's no choke, but then I can now I can change this to choke flow model using default multipliers, which is the option number 1. I think it was given here, yeah.
Only the front one.
So, a little bit complicated, but you have to dive into this system. Now you can see that there is a default choke. It's been chosen here at the outlet of the valve. So now these choke flow things are considered right, and I think we would be ready with no errors and no something we could do our calculation. I hope that it works. Because I can try and if it works or not. For this, I have to always check that my job streams are conditioned and the names are trace is default, and then single step name I want to change that it's a button trace. I think it doesn't work. And then it's a very long name, boiling water reactor system. I hope it's now okay, and I can from the tools and then submit job. Then I can do the calculation. I didn't check that's what my options are for the calculation of timing, but you can do that from the time step varying systems. But now let's do the first. And probably there will be some warnings left, but we checked out first with warnings that were not so meaningful, so we can continue. And then it makes the calculation. I hope it works. It is not doing something. Hope it really works. It seems that I can find it here in a job status system, and it calculated 100 seconds and reached the end of the problem. Then I can briefly check out what my results are by opening this yellow icon, which refers to the APT plot. And then I can check out, for example, does my valve produce any mass flow rate? For example, the total mass flow rate or liquid. I can pick any total mass flow rate and I can see that gives me this kind of value. So my valve is very small and this is not the real case, but I can see that here is something different between liquid and total, so probably there is some gas mass flow rate as well. Okay, but this way you can do the calculations and so on. And probably not too much of this case anymore, so we can continue. What else? Say, yeah, and if you want to make this other case with the pressurized water reactor, so it's quite easy to modify this to be the pressurized water reactor. It's just you check out your valid initial conditions so that the pressure you can change it quite easily to 100 and whatever the we were assuming that what the values are. On PVR case 155 megapascals and 328. So a little bit calculation between is needed for the how much is temperature 328 in kelvins is 273. So it means 559.
601.
Oh, actually it's 600. I would guess. But you have to check that. I assume that's a little bit less than. I put here some values. Value here, which is
309.
not correct, but you have to
500. 590.
go through that. So now I have changed my case, and you can find it that I have to assume that my system is full of water, and I have to put the gas volume fractions to 0 for every place. And also these other parts which were supposed to have this, I can
Yeah, it's 500.
it's quite fast and easy to check these as well. Well, this is a valid condition. Only thing I have to change is one side. And not 50. So, okay, but this is a more or less demonstration of how to work with the case. And you should all more precisely follow the instructions and then modify the parameters so that they are in good condition. Because time is running and maybe Alexander promised to give you the instructions for how to continue with this.
You're not using Trabasan. No, Trabasan. That's the boring one.
No, it's so boring.
Okay. You need to leave it up. What was that? The PlayStation. PlayStation.
So Alexander will continue with this rebate system, reflooding. We will continue then. I will be here also.
This we have two tasks. This one is the blow down. Second one is the flooding. Only choices. Providing only choice.
So now music or
What?
so now you will do music?
Yes, the second case is reflood. Just we have two reflooding. So it's double T double L. But